Hi, welcome back to the channel. In this video, we are going to look at how to find the the partial derivative of a function with respect to x and y um, by looking at it from an implicit differentiation point of view. So let's see. So here's our function. Now there are two ways that we are going to use to solve this problem, right? And whichever one you're comfortable with, you can use that to solve your problem, right? So this is the function we want to find, and z is a function of x and y. So notice that what z is going to be a function of x, y. That's why we call it implicit differentiation. And now we're going to find the derivative of z with respect to x and of z with respect to y. Now, how do we do this? So the first method is we define a new function f of x, y, z to be the function itself, right? With where you make you take everything to one side, including the constant. So if I had, let's say, this was my function, right? Then I would write this. So I would write this as, I'll take everything to one side, right? This is how I would have written it, just for you to take note, right? So this is what I would do, where everything is taken to one side and it will be equal to 0. So that is how I define my x, f of x, y, z. Now, in order to find the partial derivative, right, of z with respect to x, we just mainly use this big function with respect to x over fz. And if we want to find with respect to y, that would be minus fy over fz. So this is partial derivative of this function f with respect to x and with respect to z. Now we can quickly do that. Fx, let's find fx, right? Now what is this? This is derivative of this function with respect to x. So the first time derivative of it will be 3x squared. Second term will be 0. Third term will be 0 because we don't have x on it. And the last term would be, with respect to x, derivative of this would be what? 6yz, right? Because 6yz are acting like a constant, right? And when you differentiate x, x would give us, differentiation of x is just 1 times that constant attaching to x. So this is fx. Now we can find fy similarly. It will be 3y squared plus 6xz. And we can find fz, which will be 3z squared plus 6xy. So therefore, del z del x is just minus 3x squared plus 6yz all over 3z squared plus 6xy. So we can also do this for y, which is xz all over 3z squared plus 6xy. And you can factorize 3 out to simplify it further to 2yz over z squared plus 2xy. Or you can have this 2xz all over z squared plus 2xy, right? Any of these forms would be correct. Okay, now this is how you find it using the first method. Now the second, let's look at the second method. Now the second method is just direct computation. So this is what you have as your problem. Now in this problem, what you do is you find del x of both sides. So you find the derivative, partial derivative of both sides with respect to x. Now what will happen is you can now separate, because derivative we know that derivative of sums of functions is the same thing as what? The sums of their various derivatives. So we can separate them with the derivatives. So derivative of each term with respect to x. You see what is happening, right? So this is the second method of solving the same problem, and you should have the same answer. The derivative of the right hand side is already 0. So d dx of x cubed is just 3x squared. Del x of y cubed is 0. Here is also 0. So of the last one, del x of, oh, sorry, del x of y cube is 0. But we know that what z is a function depending on x, right? So this is going to be chain rule. So derivative of z cube with respect to x would be chain rule. So differentiate z cube first. You have 3z squared multiplied by what? Derivative of z with respect to x. Good. I almost missed that. And then the next one, the last one, ddx of this, or again, 6y will be acting as a constant. So let's look at this. 6y will be a constant because x is not depending on y, or it's not depending on y. So 6y, so this can be written as 6y ddx of xz. These two functions depend on what? X. Okay. So now we can now use product rule to find the derivative of this. So let's do it here. So we can take 6y out as I just told you. Then ddx of xz would be, we'll leave the first function x and we'll find the derivative of the second one with respect to x, plus we leave the second function, which is z, then derivative of x with respect to x is 1 times 1. So this is how to define the derivative of this, and this is equal to 0. Okay, so let me come one more time. Derivative of this is 6y is acting as a constant, so you can take it out. Now you have to find the derivative of the product of x and z. Now, because we can now use product rule, which means we'll leave the first function x, differentiate the second one, which is the z, the x, plus we leave the second function, which is z, differentiate x, which would give us 1. Okay, now we can quickly write this. Del z del x, open the bracket here, 6xy del z del x plus 6yz equal to 0. Now factorize del z del x out, which is 3z squared plus 6xy, and take every other thing to the other side. When you take 3x squared to the other side, you have minus 3x squared. Take 6yz to the other side, you have minus 6yz, right? So del z del x will now be basically, take the minus, so we can take the minus out. So we have this plus 6yz all over 3z squared plus 6xy. So divide through by 3 again. I think it's pretty much clear now that we have the same answer, right? So if you check your solutions, you see that what? They give the same thing. Del z del x, we get the same thing here on both sides. All right, good. So these are the two methods that you can use to solve functions of two variables when you want to find the partial derivatives using implicit differentiation. Now, your exercise is to use the second method to find del z del y and compare if they are the same thing. All right, that is it for today's video, for this video rather. I'll see you guys in the next video.